welcome back to this week's Ecosystem Podcast. Anybody around here have EMI and EMC issues? Anybody? Yeah, I thought so. That's why I've brought in today industry guru and expert and author Ken Wyatt of Wyatt Technical Services. We are going to offer some tips, tricks, and industry trends that will help you solve your EMI and EMC issues right from your workbench. We'd like to encourage you to subscribe, and Ken has kindly offered us a free chapter from one of his books that is available for download at thedoubleecosystem.com. When you download, you will automatically be invited to our online community, and you will also receive our monthly newsletter that will provide continuing resources to help you grow in your career. Thanks for joining us today. Now let's jump into our conversation with Ken Wyatt. Well, hi, Ken. Thanks so much for joining us again. I'm excited to catch up with you since I missed you at DesignCon this year.
Well, it's nice to be here.
So I thought for our audience, we haven't talked about EMI and EMC in a while, and I know you are the EMC doctor and have taught me so much and so many through your consultancy and your company. So let's just jump right into your background, your perspective, and why you ended up focusing a great part of your career on EMI and EMC issues.
Good question. A lot of EMC engineers end up in that position either by mistake or being in the wrong place at the wrong time, and I kind of got my foot in the door at Hewlett-Packard and as an EMC engineer, and in that position, that was in the late 80s, and the R&D engineers, the designers at our division were working on about a dozen projects at once, and about half those were failing EMC, and so I really jumped into the fire at that job. But I could see the pain that the designers were facing, because largely EMC is not really taught in university or college, and so designers normally have to deal with it by failing many times, and it's very it's really hard to trial and error EMC mitigations when you don't really understand what's happening, and so I could see their pain. I brought in a lot of EMC experts like Henry Ott and Daryl Gerke and some of those notable instructors, and that helped a lot. But in the meantime, I was learning myself, and I had a chance to develop some Workbench level EMC troubleshooting techniques, and I developed those techniques through the course of my career at Hewlett-Packard and later Agilent Technologies.
So let me understand this right. So what you've observed is that people are learning by not understanding the principles that may be driving EMI, so they would create a physical product, test it, it would fail, and then they would make sort of informed or uninformed guesses at what caused the failure, and then go back to the drawing board and sort of do that over. And what you're saying is you try to get ways to measure that from the bench top before you got time in the chamber. Is that true?
Well, true. In fact, I took one of Henry Ott's ideas where he suggested developing a mobile EMC troubleshooting cart and with the ability to roll that into the the designer's cubicle or wherever they were working, and be able to perform tests right there and help them through the physics of what's happening.
I see.
And so I took that idea and developed a troubleshooting kit that eventually I wrote up in a series of articles and blogs, and now it's in book format.
So can you give us a sort of a peek of what a few of the things on that cart was?
Oh, sure. The key ingredients were spectrum analyzer, of course,
Hmm.
some near field probes, an RF current probe, which a lot of designers weren't really familiar with that, but it's a way
Mm,
to measure minute RF currents on cables. And
mm,
because cables are generally the biggest offender for radiated emissions, it's nice to be able to characterize those currents. An oscilloscope is pretty handy as well. And then, of course, ferrite chokes and copper tape and aluminum foil.
the aluminum foil cracks me up. Do you put that on your head? There's a geek
It's
joke
actually
in
quite
there.
useful.
I bet. That's funny. So, as you kind of went through this over the course of your career, can you give us a few examples of the the most common sort of problematic areas of emissions or problems that engineers see?
Oh, great question. Yeah, there's really three very common failures that crop up almost all the time. Of course, the top one is always seems to be radiated emissions, and that's dependent on so many variables in your product that you really have to understand design for compliance right at the start
Mm,
for EMC. And if this was taught in upper class college, that that would change the picture quite dramatically. But
mhm,
yeah, so radiated emissions is always number one. As products get smaller and smaller and more mobile or body worn, and the circuit boards get smaller,
mhm,
and the voltages that drive these circuits get smaller. We've gone from 5-volt logic to 3.3, and some memory and processors use zero point 0.9 volts or
mm,
lower. And so the noise margin decreases to the point where
mm.
electrostatic discharge now becomes an issue, because it doesn't take much to disturb some of these digital signals anymore.
Right.
So ESD and irradiated immunity, where nearby RF transmitters or walkie-talkies can affect your system easier. So those are the
Mhm.
three: is radiated emissions, electrostatic discharge, and radiated immunity are really the top three that I have been dealing with for over 30 years now.
You and I have been on a little bit of a journey together over the last several years in which you were publishing the series of books you mentioned earlier, that address some or all of those. So, um, eh, I've been watching you a bit on LinkedIn, which is why I want to reach out to you. And I'm seeing the feedback people are giving you in regards to those books. So, can you give our audience just an overview of what those book titles are and how that can help them get out of this EMC conundrum that they find themselves in?
Sure. So this was actually an interesting project that I took upon myself during the pandemic. My my business decreased, pretty much went off a cliff, and so it gave me some free time to actually do some writing. And so the first book I introduced was called Create Your Own EMC Troubleshooting Kit. And I made that a volume one. I had the idea to make it 3 volumes. So that first volume went through lists of different tools and probes and accessories that I found useful in my own troubleshooting. And a lot of those items and instruments I have had a chance to review and use over the years. So I was able to provide some commentary and review and so forth. And that book was pretty popular when it came out in October 2020. I followed up with volume 2, which was all about emissions. And so the focus was really radiated and conducted emissions, and the techniques that I've developed to help troubleshoot those. It's also full of specialized measurements that help you understand some of why we get failures in emissions. Volume 3 is all about immunity, and so the major focus there is electrostatic discharge and ways to trace the ESD current. Once you know the path of current, you can add some mitigations easier. It covers radiated immunity and some really clever, I think, ways of inducing immunity failures right on the workbench, using localized RF sources. And we also cover things like electrically fast transient and some of the other immunity tests that you run into.
So, what's been the feedback? I've seen some kind of anecdotal feedback, as I said on LinkedIn. One that I thought was really clever and really, provoked me to reach out to you is somebody had posted their, in front of their desktop computer, and they said something like, I always do EMC, Workbench, whatever. And he just had all 3 of your books. Here's my EMC troubleshooting. And he just had all 3 of your books on the table. So I thought, boy, it must be received well if, they're giving you that kind of feedback. What kind of things are you hearing from people who have been accessing your books?
I'm hearing a lot of good feedback. The books are sold, actually print on demand through Amazon, and
Okay.
Amazon happens to have their marketplace websites pretty much worldwide, and so
Oh, that's nice.
worldwide sales have been really good. I've been blessed with some good royalties,
That's
and
nice.
the feedback has been great. Engineers and designers, I really wrote these for product designers, not so much EMC engineers, although
Right.
a lot of EMC engineers are appreciating the books as well. But
Right.
I'm getting some good feedback, and the sales still are good.
That's
We've had
great.
some fun on LinkedIn, doing some contests and things. Volume 1 I re-released as a second edition several months ago, and I offered, if you anybody that shows me a picture of all 3 volumes on LinkedIn will get a
Aha.
free upgrade to edition 2, and so several designers and EMC engineers took me up on that offer,
I
and
see.
I
That's
gave
where
out
those
several
came
free
from.
copies all over the world.
Oh, that's nice. What a clever
But
marketing
yeah,
idea. Well, um, so to our audience, I'm going to make sure I really wanted you to know about these resources because of things I've been seeing on LinkedIn, and I've known Ken for a while. And the thing that was surprising to me is every time I talk about EMI or EMC and I put that in the title of a podcast, the numbers spike. And I'm like, oh, Ken's not lying. This is a big problem, right? Because you can tell people are really, and so, this is why I wanted to revisit this subject to make sure to get, for people to connect, go ahead and connect with Ken on LinkedIn. He has a consulting company and these books, and we're going to put all those links for you in the show notes. I also wanted to add right here that I talked my dear friend into sharing with me a free chapter excerpt so you can get a sneak peek of the content. Ken, please remind me what that chapter is about?
sure. It's chapter 3 in volume 1, and it covers near field probes. And we
Okay.
give several examples of near field probes that you can either make or buy, and some of the pros and cons, I guess, of different near field probes and how to use them and so forth. So it's it's kind of a neat deal to introduce you to the books.
Yeah, I like that. I have a question because I have a little background in the RF and wireless and field at board level, of course. But one thing I observed is, we've been hearing for years now, right? The Internet of Things. Now it's the Internet of Everything. And in my mind, I'm like, oh, this is going to create a little bit of a disaster because now that things with RF are being integrated in standard products and engineers are sort of getting baptized by fire into RF. And I'm thinking, oh man, there's going to be EMI issues. There's going to be, and so what's your experience there? Am I pretty right on about this new messy introduction?
Well, one trend that I've seen over the past almost decade is that manufacturers are starting to incorporate wireless technology either within existing products or new products.
Mm-hmm.
And the problem that I see from an EMC point of view
Mm-hmm.
is that there are a couple dominant energy sources on the circuit boards themselves that tend to
Okay.
couple in to the wireless receiver and
Mm.
cause it to lose sensitivity.
Mm.
And this is especially bad for products that utilize cellular LTE bands in the 600 to 800 megahertz band in particular.
Mm-hmm.
And I'm finding that digital bus noise is broadband enough to reach up in those hundreds of megahertz, as well
Mm.
as DC to DC converters, which is really the the worst noise source generally on the circuit boards, and it's not unusual to have 3 to 5 of these DC to DC converters on your board, and if their broadband switching frequencies get up into the cellular band, it can reduce the sensitivity to the point where the cellular providers won't allow the product on their
Mm.
system
Oh, I
because
see.
they require a certain sensitivity in the
Interesting.
receivers so that they don't have to boost their transmit power on the cell sites
Oh,
which can
interesting.
cause cell site to cell site interference and so forth. So certain sensitivities are required, and if you don't meet that sensitivity, again, like any EMC issue, it's back and forth to the test lab and trying to figure out how to reduce the couplings of these energy sources from getting into your receiver. And so
Hmm.
that's actually a chapter in the emissions book of Volume 2.
Okay, that
There's a
was
whole
going to be.
chapter on wireless, designing your product to reduce these um, onboard energy source couplings.
Hmm. That was what I was going to ask you, is if this was covered in your books, because I'm seeing a variety of pain points being raised over this issue, and they're all different, including this one. That's interesting that the signal actually gets, what's the word?
Well, and it's dependent a lot on the
Compromise.
stack up of the board. It turns out
Oh, interesting.
the general, if you understand the physics of digital signal propagation within a circuit board, um, you'll understand that digital signals propagate as electromagnetic waves that
Hmm.
propagate between the circuit trace and the return plane. And if that path is broken anywhere, that electromagnetic wave in the form of a digital signal, or say a DC to DC converter switching noise, can leak out throughout your board and couple into the wireless antennas or directly into the receiver itself.
Hmm.
And so, if you don't get the stack up right, where every signal layer needs to have a solid return plane, and every power layer has to have the same, then you're leaving yourself wide open for internal couplings within your circuit board that can affect the performance of the wireless device.
So, say in regards to the stack up, um, I was speaking to actually a company who is a sponsor of the podcast, Obvious Tech, and they're trying to get, typically stack up modeling software has really looked almost singularly at impedance. And now they're looking at, their tools are becoming available to look at these other things, which I think is really empowering. And I know Keysight has come out with something that there's more than one company trying to solve this through better software insights.
Oh yeah.
Um, so you obviously address this in your book, and you mentioned Henry Ott, who is really iconic, getting up in years, but so many engineers I know cite him as a great teacher, or reading books or meeting him in person. For our audience, is there, besides your books and perhaps Henry Ott, um, or finding tools like the ones I mentioned, what other recommendations? Sometimes I don't want to bring up the problems without giving good solutions. So are there other resources that were particularly helpful to you along the way, or that you would recommend outside the books that you've carefully
Oh
curated
sure.
through the School of Hard Knocks and experience?
Yeah, I actually have a list of recommended books in Volume 1,
Oh, great.
and there are several very good ones out there. Henry Ott's book is good, and Dr. Clayton Paul is a good one. But there are many books out there that are really excellent. Dr. Eric Bogatin has written several books on PC board layout and signal integrity and power integrity.
Hmm.
And there's a signal integrity, power integrity, and EMC really all go
Hmm.
together.
You sure do.
If you get one right, you generally get the other two right.
Yeah.
So they're all related.
They certainly are. One thing I always cracked up that Steve Sandler told me, he says, Judy, do you really think when the electrons are moving around, they raise their hands and say, I'm a signal integrity electron? And the other one says, I'm power integrity. He goes, they're all electrons. It's how they're interacting with different things. I'm like, that's hilarious.
Yeah,
But
yep,
I've learned from people like you and Sandler and Bogerton that it's kind of like a Venn diagram, and they interact at
that's
different
right.
ways based
Exactly.
on physics. So, well, great. Thank you so much for sharing your knowledge with the audience today. It's been a delight to catch up with you and to share these resources. And congratulations on all 3 books. I guess that's a silver lining to COVID for you. Yeah, tell our customers the name of your company. They can obviously connect with you on LinkedIn. And I know that you do consulting, with companies directly and some training. How else can our audience tap into you and your company, Ken?
Actually, the best way to connect with me is either through LinkedIn or through my website, emc-seminars.com.
Okay, great. For our audience, I'll make sure and share those in the show notes. Ken, I know you're a busy guy and I got to let you go, but thanks so much for taking time out of your busy schedule to share
Well,
share
thanks so much,
your
Judy.
yeah, it's always a joy to spend time with you and learn from you. For our audience, thanks so much for joining today. I'm positive you've gleaned some good nuggets from Ken Wyatt, and thanks for joining us today. I'll put all the resources we've discussed in the show notes. Please, please, please take a moment to subscribe and like so we can bring you more great experts like Ken Wyatt. We'll see you next week. Until then, remember to always stay connected to the ecosystem.